All right, well, good early afternoon. My name is Cameron Nixon, and today is Thursday, March 19th of 2020. And we are dealing with a remnant or a remaining stubborn southwesterly broad mid-level jet left over from yesterday's happenings in Texas. We actually had a extremely long-lived, fascinating supercell just carried by this flow from Fort Stockton to the Oklahoma border, producing numerous tornadoes, likely many of which will not be rated to their full potential. But this was a pretty interesting event. And now, obviously, the question remains, what does today have that yesterday did not, etc.? But today is one of those days that really starts, I guess, bending the laws of spatio-temporal forecasting, because you have a very long window, both in space and time, for severe to happen. So even though probabilities at one point may be very low, might get probabilities to accumulate over time over a certain area just because they're under the necessary ingredients for a longer period of time, and they have more opportunities to have convection roll through them and utilize those. So what do I mean by that? So here is our upper level flow. This is going to generally correlate with the direction of motion of any storms. And what you'll notice as we scooch toward the midday into early afternoon, this is very homogeneous flow direction. There's really not much change in speed or direction, and I'll go through the lower levels of the atmosphere too, but this is typically going to mean that there are not too many significant changes in hodograph shape. So barring differences in convective mode, which we'll get to, storm behavior will be largely similar throughout the entire event. As we move down toward 700 millibars, you again get this kind of homogeneity and flow. Now we start to pinpoint the state of Iowa. It starts differing from the rest of the outlook area. So this is something to keep in mind. Iowa is the one state that convective mode and type is going to be slightly different. Going down to 850, again, that homogeneity, especially robust into Illinois and Indiana. And let's just go down to the surface. Similarly, well mixed, 10, 15, 20 knots throughout the warm sector, with the exception of the state of Iowa, which again we'll talk about in more detail later. Dew points, we have a very broad, again is the word, warm sector advancing continuously up into the Midwest. And what that's going to do is create this very large wall-to-wall coverage potential for severe weather. And with that very strong, fast upper-level flow, any storm theoretically will yield almost twice the impact as a storm would going half the speed, right? Because if you have it take a supercell moving from here to here, and it produces a swath of, let's say, hail and a potential tornado, it will impact twice as many communities if it takes that twice as fast storm motion and covers twice the ground area in that same amount of time. So this is why these events can lead to very widespread severe weather, because again, you're opening up a very long track for these supercells to potentially go. Again, that's what happened last night in Texas, where you had a very broad warm sector and that flow just carried the supercell really as long as it wanted to go. And today, we might get a supercell or two to pop off in a random location along this kind of dryline cold front feature, and it has a potential to continue for as long as it wants to throughout this warm sector. Does that mean there are going to be extremely long track tornadoes today? No. Does that mean that an individual convective element may last for hours at a time and traverse hundreds of miles? Yes, it does, and this is the kind of event that would do that. So, knowing this, we could jump to convective available potential energy, surface based. I don't feel like I have much of a problem using this today, especially because of our low boundary layer heights. However, you see that general increase in CAPE throughout the day, and this will kind of outline your potential risk areas, because shear is, again, roughly homogeneous throughout this entire area. So, and then you can start, as I flip forward and back, you can start to pinpoint some areas on the map that are subjected to sufficient values of CAPE for convective growth for longer periods of time. I'm specifically focusing and honing in on the northern Arkansas into Missouri, into southern Illinois, into Indiana. And again, this is how you increase your probability simply of severe weather, because you have ingredients over them for longer periods of time. However, this instability does ride up into Iowa, up into, or I guess down into northern Kentucky, even into southern Ohio, even into West Virginia, which I know is not currently outlooked by the SPC. But we're going to have to talk about forcing in order to ascertain whether or not that is a viable option. So I guess the question does remain, what is forcing our storms today? Currently, if we take a look at, it got rid of my radar. There it is. If we take a look at what is going on, we have a muddied, icky cloudiness overspreading pretty much all of the outlook area. However, you do have these quasi-linear multi-cell clusters just kind of floating through. So anything today, I like to think of things today, during days like today, as convective elements. You have an element of convection that is already ongoing. You have a hunk of instability that is currently riding through this warm sector, if you will. And any of these, as long as it's subjected to a sufficient amount of shear and is able to break off from the rest, do have the potential to become supercells or even grow downscale from these sort of clusters. So as long as you have a piece of convection that may serve as an initiation point for a supercell, or otherwise another convective mode capable of different hazards. So as we kind of pump this moisture into the area throughout the day, we don't currently have ample enough buoyancy for these little riders right here. But I'm assuming once that moisture does get to them during midday, these could start to produce features that resemble supercells, and or supercells could form during interactions with cold pools and boundaries and what have you. So these are viable initiation points that would put areas such as northern Arkansas, southern Missouri into the Boot Heel, into southern Illinois, southern Indiana, northern Kentucky. Basically, this will just help outline the Storm Prediction Center's current 10% risk of tornadoes, which does make sense. However, some damaging wind gusts are probably possible in this area too. As you can see, there are bow echoes taking shape already. So, where else could we get initiation? We do have, as I mentioned earlier, kind of that sharpening dryline cold front deal. I guess I have not checked to make sure that is a cold front. However, that is kind of a moot argument right now. So generally, anywhere up and down this line, you will have an opportunity for convection to pop. And I'll go over later whether or not that could be sustainable or not. We also have an advancing warm front currently sitting more closer to probably middle of Missouri, and that will advance throughout the day into areas of central Indiana into southern Ohio, even more northward, potentially even reaching Michigan and middle Ohio before instability really starts depleting. So as with a lot of events, pretty much anywhere along the warm front could be fair play. That's why I also believe that portions of northern Kentucky into the Cincy area, into West Virginia, could also be upgraded for some type of severe risk, most likely tornado or wind. Now we move up into Iowa. The one thing different about this target compared to the rest is the photographs. As we saw earlier, we have more backed, weaker low-level flow and a weaker mid-level flow. And we have this is the wrong section. We have a cold core low setup as we are overspreading significantly cooler air in the mid-levels over this great state. So what this is going to do, again, is change the sort of mode of convection, most likely. However, it does appear that there is a pretty strong risk for supercell growth due to a very pronounced forcing up there. In addition to, so this is positive vorticity advection. This will serve as our upper level forcing as well as rapidly cooling mid-level temperatures. But perhaps most importantly, very sharp dry line cold front feature with a sagging kind of warm front, effectively a stationary front at this point. So any of these could serve as foci for a few supercells in here. So now that this is all said and done, I believe I've covered all the possible forcing mechanisms. You could easily see why there is such a broad area of potential convective risk, and this is a very difficult forecast because we need to establish which areas are more likely to initiate, which areas are less likely to initiate. So I do believe, again, this area near Iowa, from extreme southeast Nebraska into Iowa, has a very good chance at initiating some supercells given the shear. And I also believe there is a moderate chance that you do get something initiating along this warm front through these sort of states. Obviously, things may initiate further down, coincident with these currently drifting small mesoscale convective complexes throughout this area. But I'm least certain about anything initiating along this portion of the dry line. As the RAP shows, it is actually pretty diffuse, and I believe the Achilles heel for a large area of today will be two things. If any convective complexes were to kind of stroll through this area down here, this would basically leave a dew point wake or an instability wake in their place. You can kind of see this modeled via dew points, but if you pull up CAPE, basically get the sense that if a complex rolled through here with a strong southerly surface flow, it might kind of leave the rest of the state of Illinois and its border with Missouri in a kind of wake where instability is not enough to sustain convection. I also believe that the second kind of Achilles heel for this, let's just use COD, is actually mid-level relative humidity. And, this seems rather simple, but in order to get convection, you need lift, you need instability, and you need moisture. What happens when you don't have moisture? We have a lot of moisture near the surface, but we also need deep layer moisture to sustain that convection and to prevent entrainment of dry air that might squash your updrafts. And one of the reasons why I'm pretty pessimistic of any convection forming in the middle of the state of Illinois, in the middle of this region, which Storm Prediction Center also highlights, is this lack of mid-level moisture. And we can kind of take a random modeled sounding throughout in the middle of this region. And if that will load on us, you can see that there's a pretty pronounced dry nose. And so I'm not sure if this is deep enough or pronounced enough to have much of an effect, but I've seen these sort of high shear events really struggle, especially when you get these deep dry layers closer to the ground. So with that aside, what are our supercells likely going to do today? Again, it's not entirely a supercell mode. There's likely going to be a mixed mode, like we investigated here with these Boeing segments that might deal damaging wind. So it seems pretty plausible to say that most of this risk area should be under a threat for occasional damaging wind. This might get tampered by weak, low-level lapse rates, as we could see in just about any sounding we pluck down in the southern outlook area. So again, this may not be too friendly to downward momentum transfer and thus limit our damaging wind threat. However, I do not believe we have this issue up in the northern target with a little bit more drier air aloft, again, as we investigated earlier, and a lot more low-level instability. And that is that is another thing that is very different about the northern target into Iowa, is that we have a lot of instability due to that very cold air aloft and similar dew points as we have down south. So looking at this, we could just use this as an example because it's very fitting of what the rest of the environment is around that northern target. Photographs are largely straight. We do have a lot of shear in the lowest 3 kilometers, which will bode very good for supercell storms and perhaps longer-lived supercell storms. And we do have robust instability. So if any supercell is able to overcome this very dry mid-level air, it might take a few tries to get some storms established up here, but especially with that very strong forcing around the triple point of that dryline stationary boundary, longer-lived supercells do seem a possibility with some swaths of severe hail looking at this photograph. Perhaps a weak tornado or two. I'm not really expecting tornadoes to be too much of a threat up there with the straight line photographs. And the very weak critical angles. These weak critical angles, like especially under 40 or so, really limit a supercell's ability to basically just wrap up and produce a tornado. And that's usually evident on radar observations. We don't quite know why yet, and it's just an association. But the rest of the outlook area, photographs actually look slightly best in this Illinois, eastern Missouri into western Illinois region, I've noticed. Pretty large and looping and generally supportive of tornadoes, potentially strong ones. This is actually not what I was thinking it would be, but it is still a viable option for tornadoes, especially with any longer-lived supercell. Photographs in the south target continue to improve. I'll just poke one around the Missouri boot heel. And you get, again, critical angles get a little bit larger, and you have a lot of SRH for tornado formation, and still lots of 3 kilometer cape. So definitely any supercell that remains in this environment long enough might have the potential to produce tornadoes. I don't know if I mentioned this, but all photographs throughout this area are biased toward longer-lived tornadoes and mesocyclones, as far as I have grown to know them as. And we can scooch forward. We could test out the Cincy to West Virginia target just for kicks and giggles. And again, kind of a very classic southeast style photograph with all in the upper right quadrant, very strong low-level shear, and some strong veering in the upper levels with decent amount of low-level cape. So again, yeah, a very heterogeneous or homogeneous target area, basically capable of supercells with potentially longer-lived, potentially significant tornadoes. Again, that will depend on how long a supercell maintains itself, and then a smattering of probably some hail reports and a brief tornado possible in the state of Iowa. And this will continue on overnight. Again, we see that some areas down toward the Ohio River Valley are still subjected to that cape, even through the evening and early morning hours, with photographs that might gradually become slightly less favorable for tornadoes later on, but any sustained supercell may still have the potential to produce a longer-lived tornado. So I hope you enjoyed this discussion, and as always, I am interested to see what happens today. Have a great afternoon.